integration. We are discussing about integration. What is this integration means? Here we are taking the small part. That is a small example. That means I am giving just information that by taking the small part, small divisible part, and making it by using that we are making the big whole one. We can say it is called as integration. So here, okay, for integration, what we need for physics point of view means the main formula. What I need here is integral x power m. Integral x power m dx is equal to, I can write here integral x power m dx is equal to x power m plus 1 by m plus 1. X power m plus 1 by m plus 1. This is the basic formula which we require for integrations. In differentiations, I think you remember the formula d by dx of x power m is equal to m into x power m minus 1. This is a differentiation formula. And now we want to discuss about integration. So, okay, I will leave this differentiation now. Already, I think you are cleared with differentiation with last class. So, integral x power m dx equal to x power m plus 1 by m plus 1. So, how to apply this formula in different situations we have to study now. The first thing, the basic application. First we will see basic application, that is suppose integral x square dx is given. Integral x square dx. So, integral x square dx means happily from this formula we can observe here m is some constant, here 2 is constant, here m plus 1 by m plus 1. Obviously we can write x power 2 plus 1 by 2 plus 1, and we can write it as x cube by 3. Okay, it is a very simple one. Again, I can also write integral x cube dx suppose. Same, no beta, same here also. See, here the 2 is there, 2 plus 1 by 2 plus 1, 3 is there. So, simply 3 plus 1 by 3 plus 1. So, I can write it as now x power 4 by 4. So, actually one more thing is there, we have to write plus c and all those things I am not writing here. Just the basic formula idea I am only discussing here. So, the two things I will discuss, two examples here. Let us go for further. Now, let me take suppose they have given only integral x dx. Integral, this is symbol, this line is called as integral x dx. Now, what happened? Integral x dx it is called as, and I can write it as, if they have given only integral x dx means it indicates x power 1 dx. X power 1 means happily I can write x power 1 plus 1 by 1 plus 1. So, nothing but x square by 2. Like that I can write. Suppose they have given only integral dx. They didn't give anything now, simply integral dx. That's all. So, integral dx means we are integrating with respect to dx. We are integrating with respect to dx. So, for that purpose, what I am doing means I have taken integral. So, dx is there, no? Dx is there, no? So, connecting to that one, I am taking x power 0. Why you took x power 0? Because this integral dx I can also write as 1 into dx. So, 1 means what should I write? Anything power 0 is 1, x power 0 is 1. So, x power 0 is 1 means what should I write now here? Integral 1 dx I wrote. And why you selected only x power 0, sir? Why you didn't select y power 0 or m power 0? Y means we are integrating with respect to dx. Integrating with respect to dx. So, we have to take 1 as in terms of x. In terms of x means x power 0 is 1. X power 0 is 1. So, that I have written here x power 0 as 1. Okay, beta. So, that what should I write now? X power 0 plus 1 by 0 plus 1. 0 plus 1 by 0 plus 1. So, what will be my answer now? Yes, answer is x power 1 by 1, simply x. Sir, is it necessary to remember all these things, sir? No, beta. Simply remember, no need to do all these things. Simply integral dx means x. That's all. Don't worry about all these things. If you don't know, leave it. Simply integral dx is x. That's all. Integral dx is called as x. Now, let us see. Now suppose they are asking integral dy they are asking. What is integral dy means y, that's all. There is nothing to think about it. One integral dx means x, integral dy means y. Like that I can write. Now suppose they have given integral 2 dx, integral 2 dx. When they have given integral 2 dx beta here, the problem is 2 is constant, 2 is constant. Always keep the constants outside the integral. So 2 into integral dx I can write. So 2 into integral dx if I am writing means integral dx I am writing means already just now I told integral dx is nothing but sir x. So integral dx is x means I can write 2x. That means here 2 is some constant. 2 is some constant. Suppose integral 3x square dx is given. 3x square dx means how to write? First to take 3 outside. Integral of x square dx. Integral of x square dx. And x square means what should I write? X power 2 plus 1 by 2 plus 1. That is nothing but 3 cancels and x power 3. 2 plus 1 is nothing but 3. So I can write x cube. What we did just analyze 3 first kept outside integral x square dx. X square dx means from our formula. What is our main formula? X power m plus 1 by m plus 1. From that formula just I applied this one. X square dx means I can write x power 3 by 3. This 3 is cancelled. This 3 and 2 plus 1 3. This 3 is cancelled and I am left with x cube. I hope you are clear till here. Fine. So this is like that. If you have taken some combination terms like this, see observe now. Suppose they have given integral x square plus x plus 1 dx. They have given to us. How to handle this one? Here integral x square plus x plus 1 dx. Then immediately separate all the terms. Take individually each one integral x square dx. Next integral x dx plus integral 1 dx. So I separated all the terms here. I separated all the terms here. So here integral x square dx already we discussed. X square means what will happen beta? Yes, x power 2 plus 1 by 2 plus 1. And again here only x is there. I told you that only x means power 1 is there. 1 plus 1 by 1 plus 1 we know. And integral 1 dx means nothing but integral dx is nothing but x. So my answer is x cube by 3 plus x square by 2 plus x. That is my answer. Very easy, nothing to get worried. So take each individual term. Integral x square dx already we know. Integral x dx already we know. Integral dx is nothing but x. Just substitute it. Fine. This type of things are good. Again, here what happened means here in differentiation I have one term here. Differentiation of sum c is equal to 0 where c is constant. Where c is constant. That means if I differentiate the constant, I am getting 0. Differentiation of constant is 0. Any constant. So differentiation of constant is 0 means what will happen? Differentiation of constant is 0 we told. Now what will happen to the integration? Integral of 0 dx. Generally, it is a reverse process, but a differentiation integration is almost reverse process. So, integral 0 dx. What is integral 0 dx? Integral 0 dx means is nothing but some c, where c is called constant. C is called constant. So, integral 0 means don't say answer is 0. So, integral 0 dx is some constant because differentiation of constant is 0. Integral 0 dx is some constant. Integral 0 dx is constant. That constant I am representing with c. Like that I can write better. You have to remember this one. Just analyze, nothing to get tensed. Differentiation of constant 0. Integral of 0 is constant. Reverse to the differentiation with that means whatever we did here means just we reverse the differentiation. We got the integration. Okay, I hope you are clear till here. Let's see one more thing. Here what I am doing is I have taken here integral of 1 by x square dx. What is integral of 1 by x square dx? Integral of 1 power 1 by x square dx means how to handle this one means immediately you have to write like this. Integral of x power minus 2 dx. Integral of x power minus 2 dx. Now, what is our main formula? Main formula means our main formula what we have for integration, integral x power m dx is equal to x power m plus 1 by m plus 1. These are main formula. Here integral x power minus 2 is there. So integral x power minus 2 is there means what should I write beta? Yes, x power minus 2 plus 1 by minus 2 plus 1. So what will happen here means I can write here x power minus 1 by minus 1, or I can write minus 1 by x. So I hope you are clear now with this one. So here what I noticed is integral of 1 by x square dx. So x square you take it to the numerator, it will become x power minus 2. Again integration formula I am applying here. That is this m is minus 2 now. As m is minus 2 I can write here minus 2 plus 1 and minus 2 plus 1. So x power minus 1 minus 1. So I can write minus 1 by x. So integral 1 by x square dx is minus 1 by x. Integral 1 by x square dx is minus 1 by x. Somebody asked me, okay sir, you did like that, what is the differentiation of 1 by x? Differentiation of 1 by x they are asking me. Okay, differentiation of 1 by x means I can write it as, differentiation of 1 by x I can write it as d by dx of, what should I write now here? Yes, x power minus 1. So d by dx of x power minus 1 means in differentiation or formula, did you remember differentiation formula? D by dx of x power m is equal to m into x power m minus 1. This is differentiation formula. That is whatever the power is there you have to bring here. So observe, here the power is m, here power is minus 1. So power is m here, m is minus 1, so I will write minus 1 here, minus 1 minus 1. Let us check what is happening here. Yeah, minus 1 into x power minus 1 minus 1. I can also write that as minus 1 by x square. Minus 1 by x square. So I hope you are clear with this differentiation thing. Actually, they didn't ask us differentiation, they asked integration. I want to confirm that if you observe very particularly these two things, 1 by x square dx, integral 1 by x square dx is minus 1 by x. Differentiation of 1 by x is minus 1 by x square, minus 1 by x square. Why minus 1 sir? Why minus 1? Observe beta here, 1 by x, d by dx of 1 by x is there. X by x will come to the numerator means x power minus 1. X power minus 1. So here actual formula for differentiation what I told just now I informed you, d by dx of x power m is m into x power m minus 1. Comparing these two, what is m value beta? Yes, m value is minus 1. M value is minus 1 means now what should I write here? Yes, minus 1 into x power minus 1 minus 1, that is minus 1 into x power minus 2. Happily I can write like that. Is it clear beta now? I hope you are clear now how we got minus sign there. Is it clear? So this is about differentiation also. So we compared differentiation and integration, the two things now. Okay then. I hope you are clear with this one. One question is there like this beta. What is integral of 1 by x dx? Integral of 1 by x dx. So integral of 1 by x dx is nothing but beta log x base e. Log x base e. Log x base e. Don't do for this one. This is a special case. You must not do sir x 1 by x, no sir x power minus 1 dx. So I can write this as x power minus 1 by minus 1 minus 1. You must not do this method. You must not do this method. Okay beta, you must not do this method. So here this is a case where integral, this is also one special formula, integral 1 by x dx is log x base e. I think you are clear with this 10th one. Here, see here, integral 1 by x square. This one is okay. You can take it, this 1 by x square. Is there no x power 2? I can take into x power minus 2. And I can do this one. This is the integration value and this is the differentiation value. Two things I explained in the same question. That is, I explained differentiation as well as integration. That is not the same question. That means I want to connect these things and then I made like that. I connected 1 by x square dx means minus 1 by x square minus 1 by x and 1 by x differentiation minus 1 by x square. So I want to show the comparison with the differentiation and integration, how they will be valid. Okay, fine, leave it about that. Now coming to here, integral 1 by x dx equal to log x base e. So this is a special case. Actually, d by dx of log x base e, d by dx of log x base e is nothing but d by dx of log x base e is nothing but 1 by x. 1 by x. So d by dx of log x base e is 1 by x. Here we can also write this one as ln x. Remember, sometimes you people are confused in the question. They don't mention log x base e. Simply they will write ln x. That's all. They will write like this, ln x. Ln x means nothing but it says that log x base e, log x base. They don't write log x base e. So many times I found simply writing ln x they will write. You must not get confused. I hope you are clear with this one now. So integral 1 by x dx is log x base e. Here we are not applying the formula of that is integral x power m dx. That one we don't apply this one here. Simply integral 1 by x dx is log x base e and its value is ln x. Like that I can say. I hope you are clear. These are some special cases in integrations. Now, one more thing in integration means general things you have to remember this one, that is a integral sin x dx. What is integral sin x dx means? Simply I can write it as minus cos x. But if you observe differentiation, d by dx of sin x is nothing but d by dx of sin x is what we have plus cos x, plus cos x, plus cos x. We are not discussing about differentiation in here, but I want to give the formula here. D by dx of sin x is cos x, but integral sin dx is minus cos x. What sir, what happened here sir, how you got here? Here minus is not there, differentiate, if you reverse will you have to get like that? No sir, no, here I will show you what happened actually. Integral cos x dx, if you take integral cos x dx, I am getting it as sin x. But originally d by dx of what I am taking here is, observe carefully here, d by dx of cos x is minus sin x. D by dx of cos x is minus sin x. So here this opposite is integration here. So d by dx of cos x is minus sin x means integral sin dx is minus cos x. And here d by dx of sin x is cos x. So integral cos dx is sin x. For this one, this is opposite. I hope you are clear with this 12th one and 13th one. Just remember as the formulae. No need to take more tension on these things. Just remember them as a formula. Okay, beta, integration how to apply for sin x and cos x and differentiation how to apply for sin x cos x. These are the base formula. That's all. Next. Here what happened means once they have given the question like that. Integral of sine some kx is there. Some k is some constant into dx. Generally integration is that they must mention dx. Without dx you must not write anytime integration, right? Maybe dy or dx or anything, something must be there, dt or something must be there. We are different. That means we are integrating with respect to what term? Dx term. Small dx we are taking and we are making the integration here. So here integral sin kx dx. What is integral sin x dx? Yeah, just now we wrote here integral sin x dx is minus cos x. Integral sin x dx is minus cos x. So integral sin x dx is minus cos x means obviously here integral sin kx dx is also I can write it as minus cos kx. I can write it as minus cos kx. Fine, happy here. But here internal again, if you observe, this is kx is there, kx is there. So this constant you have to divide. Simple rule I am telling. This constant just divide. So whenever they have given the constant in front of x here, that constant, because you are differentiating with respect, integrating with respect to dx, and your x term is there before, whatever the constant is there, that you write here. Suppose the same thing asked in differentiation like that. D by dx of what is sine kx? Nothing. What is the d by dx of sine kx is nothing but what we will write cos kx, cos kx. So here d by dx of sine kx. Here you observe that integral sine kx dx is there. This dx will not carry forward again. This dx will not be there. This integral of sine kx is minus cos kx, and only this constant term k is constant before x. K is constant I wrote here. But here when I am writing differentiation sine kx here, sine kx, what is the constant here? The constant is k. So I can write just k here, k outside. What I want to say is, please observe the difference between differentiation and integration. Observe the difference carefully between integration and differentiation. This constant where we are writing in integration, we are writing in the denominator, and in the k is the in constant, we are writing in differentiation in the numerator itself. I want you to observe these things. Don't get confused. Whenever you are writing integration, that constant k you write it down, and here you write it up. That is for differentiation, we are writing it up. You must not get confused. Differentiation k into cos kx. Integration minus cos kx by k. I hope you are clear till here better. So I think you are understanding what I told. Next one. So to better to understand, let me take one more example, that is the integral of cos kx dx. Or otherwise sine only I will take. Let me take integral sine 2 theta d theta. Let me take integral sine 2 theta d theta. Sir, what is sine 2 theta d theta? Now you observe, we have taken with respect to d theta. Here, so theta is variable, but 2 is constant, So sine d 2 theta d theta, they have written means, I can write it simply here. It is nothing but minus cos 2 theta by 2, minus cos 2 theta whole by 2. From where did you get this one, sir? Here you observe this one, the same thing, integral sine kx dx with respect to dx here, so x is there, dx term, so happily cos kx and whatever constant is there, I wrote down. The same thing here also, sine 2 theta d theta. So when we are doing with respect to theta here, sine 2 theta I can write as, okay, minus cos 2 theta, happy. But again, internally if you observe, this 2 is constant, you have to keep down. This 2 you have to keep it down. I hope you are clear till here. So suppose the same thing they ask, d by dx of sine 2 theta. Sir, what is d by dx of sine 2 theta? Nothing here. See, observe d by dx of sine kx. Here you must not write x here. Beta, very dangerous. D by d theta must be there. If at all here x is there, suppose x is there. Let us think x is there. D by dx of sine 2 theta means my answer is 0. Why your answer is 0, sir? Because 2 theta, is where now constant, 2 is constant. Here we are doing with respect to x, not these things. So happily we can say 0. So very dangerous. So now what should we do now? I don't want here, that is not x here in the denominator. I am writing here d theta. D by d theta of sine 2 theta. D by d theta of sine 2 theta. What is d by d theta of sine 2 theta, sir? Nothing beta. D by d theta of sine 2 theta is nothing but, first of all, here observe, carefully observe, sine kx means cos kx. So differentiation of sine 2 theta is nothing but cos 2 theta, and whatever the internal constant, the 2 you have to multiply here, 2 into cos 2 theta. Just remember like that. I hope you are clear now with this example how to handle whenever sign terms are given with a constant here, when we have to divide and when we have to multiply. Differentiations you have to multiply and integrations you have to divide. I think now you are clear with these two examples. Let me take one more example. Here 16th one, I am taking one more example here, that is integral of cos kx or cos ky dy. Why every time we are taking x and theta like that? Let me take now cos ky dy. Cos ky dy. So this is the formula. What I wrote here is, carefully observe, integral of cos ky dy. What is this integral cos ky dy? Yes, it is minus, that is cos ky dy. What we got already, I told you beta. Yeah, sin ky, simply sin ky. We don't have minus sign here, simply sin ky, as well as here internally constant is there. Just now I told to divide the total constant down, total this k down here, divide first total by k. I can write like that, by k I can write here. Here we are integrating with respect to y, and suppose they have given like this d by dx of y x. I told I will take some z now, z. Okay, we'll see the z later. Okay, if you take z, what will happen now? D by dz of what is cos kz? What is cos kz? Means what should I write? Differentiation. This is not integration, don't get confused. Here previous one is integration, no doubt. Now I am doing differentiation. Cos kz is actually, it is minus k into sin kz. First of all, cos kz is what? Sir, how we are writing this one, sir? First you have to write cos kz. Cos kz is minus k sin, sorry, not minus k will not be there. Simply cos kz means minus sin kz, minus sin kz. Happy, sir? Minus sin kz, I know. But you must not forget this k. We must not forget k. K is internal constant that you have to multiply. That you have to multiply. In differentiation, we will multiply that constant, and integration will divide that constant. I hope you are following these things. Like that, we can do these things. So these are some basic applications of integrations. In physics point of view, mainly here, what is the difference between this display? That means when we have displacement is given in function of time and they want a velocity, instantaneous velocity, then I can use differentiation. And velocity is given in function of time. Now velocity is in the function of time and I want acceleration. I can do, that is a differentiation of velocity with respect to time. This is the S is here displacement, V is here velocity, A is here acceleration. Displacement is in function of time. We got velocity instantaneous. Remember, this is not velocity over a range of time period. Simply it is instantaneous velocity. Velocity at one particular instant of time. ds by dt. Differentiate this function. Generally what will happen means, what is this example, sir? They will be giving like this, some randomly I am taking one example. S square is equal to 2 square plus 2t plus 3, like that, some random example. So I want to differentiate means v is equal to ds by dt. So here I told displacement is given function of time. Sir, what is that displacement given function of time is? They will give like that. How displacement is varying with respect to time? How displacement is varying with respect to time? That is called as like that. So now if I do the differentiation, v equal to ds by dt. So d by dt of the above one, t square plus 2t plus 3. Yeah, what is the differentiation? d by dt of t square means 2t and d by dt of 2t means 2 and d by dt of constant is 0. Like that we can do. I hope you are understanding. So telling that displacement in function of time, displacement is in function of time means they will give displacement equal to some time terms, some time terms. That means displacement is varying with respect to time. Similarly, here see, now velocity is given function of time. We can say that means I'm writing v of t means, suppose I wrote v of t means it says that velocity is given function of time like this. This is one example I have given. I hope you are clear with these things now. So what I'm saying here is here, whenever displacement is given some function of time, you will get instantaneous velocity by differentiating the displacement with respect to time. And if displacement is given function of time, sorry, velocity is given function of time, then we can get the instantaneous acceleration. So from displacement we got instantaneous velocity. We will get instantaneous velocity by differentiating displacement with respect to time, and differentiating velocity with respect to time, I will get instantaneous acceleration. Okay, I will show you this one. I'll take some examples and I'll give you. And what I want to say is, okay, this part what I just now I have given information is related to differentiation. What I told is for differentiation. This information is for what? Differentiation. So now I want for integrations. Okay, now I want for integration. Integration, I can say it is a reverse process. If acceleration is given in function of time, I can find velocity by integrating acceleration with respect to dt, because acceleration is varying with respect to time. We can also apply the limits t1 and t2, and velocity is given in function of time, then I can find the displacement over a range. This is not instantaneous velocity, remember, this is not instantaneous velocity. This is a velocity over a time period range, or a range of time period in a given interval of time period velocity. This is a given interval of time period velocity. It's not a velocity at a one particular instant like that. Here also like that. S is equal to now integral v dt. I can write v is given function of time and t1 and t2. So reverse process you can observe. By displacement you got velocity, by velocity you got acceleration. So this is a displacement from differentiate instantaneous velocity differentiate acceleration. But here acceleration integrate with respect to a time interval, between a time intervals will get the velocity range. If velocity is integrated with a time interval, we'll get the displacement range. Like that we can find these things. That means I want to inform you that when you observe the differentiation and integration, it's just a reverse process you can observe here. Reverse process. Displacement to velocity to acceleration. This is differentiation. Acceleration to velocity to displacement. It is integration. I hope you are following this one now. Next. Here, what I want to conclude here is the very important thing is about application of limits. So in the integration, you have to know how to apply the limits. So there is a given function. One function is there. F of x is some function. X1 is called lower limit and X2 is called upper limit. X1 is lower limit. X2 is upper limit. Then how to substitute the limits? Always in the function, first you substitute upper limit, because here x is a variable, lower limit is x1 and this is x2. Always first substitute upper limit in the function, minus lower limit in the function, So what we did here is upper limit substitution minus lower limit substitution, like that you have to apply. For small example, I will take how to apply the integration. Very small basic example. Integral x squared dx from 0 to x value starts from 0 to x value ends at 1. A time interval, not time interval, displacement interval from 0 to 1. So simply x squared dx I can write as x cube by 3, that we know. So lower limit is 0, upper limit is 1 means first substitute, leave 1 by 3 outside. Keep it out, 1 by 3 outside. Don't worry about 3. 3 is a constant, keep it outside. First substitute upper limit, 1 cube, and substitute lower limit 0 cube. So if I, that means what I did here, you observe substitution of upper limit in the place of x, then substitution of lower limit in the place of x. I finally got 1 by 3. I got this answer. I hope you understood now how to apply the limits in the case of integrations, because we are taking in integrations upper limits and lower limits. These are the base points in integrations. Today I explained about all the base points in integrations. I hope you are clear with today's class. Okay, beta. Thank you very much for attending the class. Thank you.